Today we're going to be starting the third unit of the course, periodic functions. Okay, we're still continuing with sort of trigonometry. We're going to start looking at it in a new way. Most of this unit should be some review from grade 11. You do this in the grade 11 mixed class, but we're going to add a few parts and pieces this unit. Okay, a periodic function, just to remind ourselves, is a function whose graph repeats its y values at regular intervals. That's the key there, the y values in regular intervals. So looking at the first graph, to trace it, I go up and then down, then up and then down, then straight up. And then I start all over again, up and then down, then up and then down, then straight up. And I could predict what's going to happen next, right? Up and then down, and then up and then down, and so on and so on and so on. The same values are repeating themselves over and over and over again. Okay, that would be a periodic function. The second one, okay, I'm tracing my pattern, and go back up. I'm tracing my pattern, and then go back up. However, the y values of this first piece and the y values of the second piece are not the same values. And looking at what's going on in the graph here, it appears to keep going down and down and down forever. So I'm not having a periodic function, so my values have changed over time. The key to a periodic is they have to be the same y values. Okay. Once we've shown something is periodic, when we look at this first one here, there's going to be 4 properties that we can find every single time that help us talk about this periodic function. Okay. Here's the 4 right here. So the first thing, a cycle. One complete set of repetitive values. So going back to that first graph, if I say this is my starting point right here, I follow my pattern until I get to that same starting point again, right there, right this point. Start all over again. And then if I went to the next one, start all over again right there. So each piece of this would be considered a cycle. I've repeated myself, repeated myself. Okay. Second property, the period, the horizontal length of a complete cycle. Okay. So how far is it between here and here, from the beginning of it to the end of it? And these cycles should always be the exact same size, right? We're not changing as we move our way through this. Otherwise, our pattern is not periodic. And in our case, the period would be 4 units. Now, our units don't have any context here, so we can't say, oh, it means something for meters, for centimeters, for seconds. So we'll just write down 4 for now. But this one's 4, and so is that one. Our third one, our central axis. It's the horizontal line that passes through the vertical center of the graph. It has an equation, max plus min divided by 2, and make sure we have this y equal part right here because it's a horizontal line. Okay, so if I'm writing down my central axis for the first one here, I'm going to start off by saying, okay, CA, my central axis. Y equals, it's a horizontal line. Okay, to find that, I can take my max value, the highest point my graph ever reaches. It looks like that right there. There's my max. Max of 2. And my min right there, min of negative 1. What I'm going to do is I'm going to average them. I'm going to add them together and divide by 2, which gives me 1/2 or 0.5. In other words, if I were to draw a line at 0.5 right through the middle here, a vertical 0.5, my graph is half the time above that and half the time below that. It's the exact center of my vertical graph. The fourth property, the amplitude, is the distance we get from the central axis to the max or min. How far from average do we actually get? It has basically the same formula, max and min, but here be careful, it's a minus sign this time. So on that first graph, same ideas. Let's move this down a little bit here. My amplitude is my max minus my min this time. Careful those negative signs in there. I get 3/2, which is 1.5. So what that's telling me is my graph never gets more than 1.5 from average. So if I find an average spot, there's the central axis, this distance here is 1.5. Okay? Right here, central axis, this distance here is 1.5. The furthest I ever get from average is 1.5. And those are our 4 properties. As long as it's periodic, we can find those every time. Okay, so I've given you 2 more examples here. Can you find those 4 properties, label them, calculate them, whatever you have to do on each of these 2 graphs that are periodic? Okay, try it yourself, check back in, make sure you got the right answers. Okay, so I'm going to start with this first one here. I'm going to say this is where I want to label my cycles. Okay, any one of these is a cycle, right? Cycle, cycle. Okay. The period of that cycle, the horizontal distance is, in all those cases, 2 units. Okay. My central axis, y equals my max. What's my max? My max is up here, right there. I'm going to say that's a max of 3. My min is right here. My min of -3 looks like. So max plus min divided by 2 turns out to be 0. The horizontal dividing point of this would be right along the axis there. Half the time above, half the time below. My amplitude, same numbers, max, but this time we're subtracting the min, right? Divided by 2 gives me 6 over 2, which is 3. I never get more than 3 above or below average. So that's 3 below. This distance would be 3 above. Yeah, that's my distance from average. You guys try B. I'm going to label a cycle. I'm going to call this, oops, that's a little crooked there. I'm going to call this one right here to this one right here. That's my cycle. And the period of that, how far is it? It looks to be about, oh, I got to be a little tricky here. The units, we're going by 2s, right? Okay, so that would be a total of 4 units. And my central axis is y equals my maximum value. That's about here. Again, it's going by 2s. So that's 2. And there's my min, which is -2. Which turns out to be 4 over 2. What's we're adding here? 0 over 2, which is 0. My central axis is 0, which makes sense. We're just looking at the graph. Half the time we're above, half the time we're below. And my amplitude, add 2 minus -2 over 2 comes out to 4, which is 2. We never get more than 2 from average, below or above. And that makes sense on our graph too.